Welcome to Seeking History. We're diving into the stories behind things that really shape our world. And today, well, it's something that's probably in the room with you right now, television.
It really is everywhere, isn't it? It's sort of hard to picture life without it.
Totally.
But getting from, a fuzzy dream to the screens we have today, that's quite a story. Science, business rivalries, huge societal shifts. It's all in there.
It really is. And just to kick things off, here's a fun fact that kind of blows my mind.
Okay.
Imagine watching TV, but the picture is only 8 by 8 pixels.
Wow, 8 by 8, that's tiny.
Right. That was the resolution of one of the very first instantaneous transmissions.
Yeah.
Back in Paris, 1909. Maybe enough for a letter, but not much else.
Definitely not binge-watching material, no. And now we've got Ultra HD streaming. The jump is just staggering.
It truly is. And that's the journey we're exploring today. We want to trace TV right from the start.
Yeah.
The early ideas, the inventors, those big patent fights.
Yeah.
And how it just fundamentally changed everything. Economies, societies, you name it.
So let's go back, way back, before anything like modern TV, to when it was just an idea, a spark.
Right, because the dream of sending images, that actually came before moving pictures. You had 19th century inventors working on facsimile machines, sending still pictures over wires.
Like Alexander Bain, Frederick Bakewell. They were laying some groundwork, absolutely. But the real challenge, the leap, was thinking about moving images. And the first attempts, they were all mechanical.
Mechanical, how did that work?
Well, the core idea often involved spinning discs. You've probably heard of the Nipkow disc.
Oh yeah, the one with the spiral holes.
That's the one. As it spun, it scanned an image line by line using a light sensor on the other side. Pretty ingenious, actually.
And people actually demonstrated this stuff.
Oh, yeah. Some really remarkable early demos, even if they look primitive to us. That 1909 Paris one you mentioned, Rignew and Fournier.
The 8 by 8 pixel one.
Yeah. They used 64 selenium cells, like a tiny electronic retina. It proved the principle worked, instant image transmission. Then you had Boris Rosing in Russia, 1911. He worked with Vladimir Zworykin, who becomes a huge name later.
Right.
They used a mechanical scanner, a mirror drum thing to send, and a cathode ray tube, a CRT, to receive. But Zworykin himself said the images were very crude.
Crude how? What was the problem?
A big part of it was the selenium cells. They were light sensitive, which was good, but they just reacted too slowly. They couldn't keep up with changes needed for moving pictures.
So the sensors were the bottleneck. Archibald Lowe in London ran into that too, didn't he? With his Televista.
He did. Around 1914, his system also used selenium cells and bimetallic shutters. It struggled, especially with reflected light. Often just got shadows, couldn't capture enough light fast enough. Though, interestingly, much later, like 1938, he patented an idea for a camera with way more cells. He saw where things needed to go, even if he couldn't build it then.
So these early guys, they were proving it could be done electrically, but the results weren't great.
Exactly. They lit the fire, though, sparked this intense innovation, and then you get figures like John Logie Baird in Britain. He was relentless with mechanical TV.
Baird was huge, right?
Yeah.
What were his big achievements?
Oh, several. He sent a signal over like 438 miles of telephone line in 1927.
Wow.
And the first transatlantic TV signal in 1928, that was a big deal.
Definitely.
He launched experimental services in Germany and France in 29, did the first outdoor remote broadcast, the Derby horse race, in 1931, even demonstrated ultra-shortwave TV in 32. His system got up to 240 lines eventually.
240 lines mechanically. That sounds pretty good for the time.
It was, though for fast action, they often had to film it first, develop the film really quickly, and then scan the film. A bit of a workaround.
Gotcha. And what about in the U.S.?
Charles Francis Jenkins was a key player there. Published ideas way back in 1913. Showed moving silhouettes in 1923.
Silhouettes, like shadow puppets.
Pretty much, yeah. In 1925, he did a public demo, sending 48-line silhouettes over 5 miles with a Nipkow disc. He even ran one of the first experimental stations, W3XK, broadcasting those silhouettes from 1928, some of the earliest regular programming anywhere.
So people with the receivers could actually watch something, even if it was just shadows.
Exactly. And don't forget Leon Theremin in the Soviet Union.
The guy who invented the musical instrument.
The very same. He developed a mirror drum system, too, got it up to 100 lines by 1927, and could even project it onto a big screen, like 5 feet wide.
Okay, so it's this global race, everyone trying mechanical methods. What's the big takeaway from this era?
The big takeaway is proof of concept. They showed moving pictures could travel through wires or airwaves, It wasn't great quality, often just shadows, but it proved the fundamental idea. And that just laid the groundwork, the absolute essential foundation for wanting something much, much better.
And better meant getting rid of the spinning discs and clunky mechanical bits.
Precisely. It meant going electronic.
Enter the electron age.
Exactly. And the key technology here is the cathode ray tube, the CRT.
The thing that was in old TVs and monitors.
That's the one. J.J. Thomson's work on bending cathode rays was crucial. And then Carl Ferdinand Braun invented the Braun tube in 1897. He was the first to really think of using a CRT as a display.
So you had the screen part electronically, but the real idea was to use electronics for the camera too, right? Not just the display.
That was the breakthrough concept. Alan Archibald Campbell Swinton in the UK proposed an all-electronic system back in 1908 and detailed it more in 1911. Use a CRT beam to scan in the camera and another CRT to display.
Did he build it?
He experimented. Tried using a selenium-coated plate scanned by a cathode ray beam, but couldn't quite get it working practically at the time. The idea was out there, though.
And this electronic approach, why was it so much better than mechanical?
Because mechanical systems just had limits. You couldn't spin the discs fast enough or make the hole small enough to get really good resolution or smooth motion. Electronic scanning promised much higher quality, sharper images, faster refresh rates, a massive leap.
But making an electronic camera tube was the hard part.
That was the major technical hurdle, yeah. Early electronic camera tubes, like the image dissector, had a big problem. They only saw the light from one tiny spot at the exact instant the scanning beam hit it.
Okay, so what does that mean practically?
It means you needed incredibly bright lighting on whatever you were filming. Just wasn't sensitive enough for normal conditions.
Right, you needed a tube that could somehow collect light over time, like film does.
Exactly. It needed to remember the light hitting each part of the picture between scans. And the person who cracked that was a Hungarian engineer, Kalman Tahani.
Tahani.
He came up with the charge storage principle, patented it in 1926, though it wasn't fully recognized until around 1930. His tube design could accumulate and store electrical charges from the light hitting it over the whole scanning cycle.
Making it much more sensitive.
Vastly more sensitive. Suddenly, you could capture images in normal light. This was fundamental. RCA actually bought his patent later, which shows how important it was. That charge storage idea is still basic to how digital cameras work today.
Wow. So Tacony's invention was the key to practical electronic television.
It really unlocked the door, yeah. And that takes us into this really intense period, especially in the U.S., the patent wars.
Ah, yes, the battle for control. Who were the main contenders?
Primarily, it boiled down to two figures in the U.S. Philo Farnsworth, this young independent inventor.
The guy who supposedly got the idea of seeing lines on a farm field.
That's the story, yeah. A real prodigy. And on the other side, Vladimir Zworykin, who we mentioned earlier, now working for the big guns Westinghouse, and later, the giant RCA.
So Farnsworth first. What did he achieve?
He developed his image dissector tube and famously transmitted his first electronic image, just a simple straight line, in his San Francisco lab in 1927.
Straight line.
Hey, it was electronic. His public demo in 1928 is often called the first proper electronic TV demonstration. And by 1929, his system was fully electronic, no mechanical parts, and could transmit live human images.
Impressive for an independent guy. What about Zworykin at RCA?
Well, Zworykin had filed a patent back in 1923 for an all-electronic system, but his demonstrations in, say, 1925 produced really dim, low-contrast stationary images. His early camera tube, the iconoscope, based partly on Tiffany's ideas later on, took years of development by RCA's team to become truly practical.
But RCA was the powerhouse, right?
Yeah.
They saw the potential and went after Farnsworth.
Oh, yeah. RCA was dominant in radio and desperately wanted to control television. They used Zworykin's earlier 1923 patent application to file a patent interference suit against Farnsworth, basically saying our guy thought of it first.
The classic corporate versus inventor story.
Pretty much. David versus Goliath. It dragged through the courts for years.
And you won?
Farnsworth. In 1935, the U.S. Patent Office examiner ruled in his favor. They found that Zworykin's 1923 patent couldn't actually produce a working television image, while Farnsworth's could. RCA appealed and appealed again, but they lost.
A major victory for the little guy.
Legally, yes. But RCA was the one with the manufacturing muscle and the money to actually build a nationwide system. So in the end, pragmatism won out. In 1939, RCA agreed to pay Farnsworth $1 million over 10 years, A lot of money then, plus ongoing license fees to use his key patents.
So RCA ended up using Farnsworth's tech anyway.
They needed it. It was a crucial business deal that cleared the path for RCA to commercialize television in the U.S. using the best available technology, including Farnsworth's vital contributions like charge storage.
While all this legal drama was happening, were stations actually starting to broadcast electronically?
Yes, some experimental broadcasts were kicking off, still pretty low-res stuff for early adopters and enthusiasts.
Like who?
Well, besides Jenkins' mechanical silhouettes, you had General Electric Station in Schenectady, W2XCW, doing 48-line electronic tests from 1928. They even broadcast the world's first live TV drama that year.
Wow.
An RCA station in New York, W2XBS, started 60-line electronic tests in 1929, and they eventually launched the first regularly scheduled electronic service in the U.S. from 1938.
And the picture quality was improving.
Steadily, yes. Resolution was going up. RCA demonstrated 343 interlaced lines by 1934. Don Lee, broadcasting on the West Coast, hit 300 lines by 1936. The big public launch, though, was NBC, owned by RCA, starting regular broadcasts with the opening of the 1939 New York World's Fair. That's when TV started to feel like a real consumer product was on the horizon.
Okay, so TV is emerging. People might actually buy these things. How are they going to pay for the broadcast?
That's a crucial question, and you see two really different paths being taken almost immediately. In the U.S., it quickly went towards commercial advertising. The FCC gave the green light for stations to sell ad time starting July 1941, though they did say stations also had to do public service programming.
And this led to the very first TV ad.
It did. A landmark moment, really. July 1st, 1941, station WNBT in New York, right before a baseball game.
What was it for?
Bulova watches. It was super simple, just 10 seconds, showed a test pattern that looked like a clock face with the Bulova logo and a voiceover saying Bulova watch time.
How much did that cost?
Reports vary, but somewhere between $4 and $9.
$4. Unbelievable.
A bit different from Super Bowl ad prices today, yeah.
Just a bit. Okay, so that's the U.S. model. Ads pay for content. What about the U.K.?
Completely different approach. The BBC, the British Broadcasting Corporation, was funded primarily by a license fee. If you owned a TV set, you paid an annual fee.
So no commercials.
Not on the BBC, no. The focus was explicitly on public service, education, culture, information, rather than maximizing ratings for advertisers. It created a very different broadcasting culture and structure compared to the U.S.
Two distinct models right from the start. But just as things were getting going, World War II happened. How did that affect TV?
It basically slammed the brakes on everything, at least for civilian use.
Yeah.
In the U.S., the FCC relaxed the rules about how much stations had to broadcast. Most cut back drastically or just shut down operations for the duration.
And no new TVs were being made.
Nope. Production of civilian TV sets and equipment stopped completely from April 1942 until August 1945. All manufacturing capacity was redirected to the war effort. There were only about 5,000 TVs in American homes when the war started anyway.
So the war put the whole industry on pause.
For consumers, yes. But, ironically, the war itself led to huge advances in electronics, radar technology, things like that.
Which helped TV later.
Massively. So when manufacturing freeze lifted in August 45, television wasn't just restarting, it was poised for an absolute explosion. You had pent-up demand, new technology from the war, and soon, post-war prosperity.
And exploded did. The growth numbers are just wild, aren't they?
Absolutely wild. Look at the U.S. households with TVs went from practically zero, like 0.5% in 1946, to over 55% by 1954, and 90% by 1962.
Wow, 90% in just over 15 years. That's incredible adoption.
It completely reshaped American life. Home life, family time, politics, culture, everything. Britain saw a similar boom maybe a little bit later. More money, more free time after the war, TV fit right in.
That kind of rapid growth must have caused headaches for the regulators, the FCC.
Oh, totally. They were swamped with applications for new TV station licenses. So many that they actually put a freeze on accepting any new applications from 1948 to 1952.
A freeze, just to catch up.
Yeah, they needed time to figure out technical standards, how to allocate channels without interference, all that stuff.
And during this boom, the idea of national networks really solidified.
Definitely. By the early 50s, you had NBC, CBS, ABC, and also Dumont for a while, building out their networks. They used coaxial cables and microwave relays to link stations across the country.
Creating a truly national audience.
Exactly. And a huge milestone was the first coast-to-coast live broadcast. September 4th, 1951, President Truman was giving a speech in San Francisco.
And people watched it live in New York.
Live across the entire country, thanks to AT&T's new transcontinental hookup. It was a powerful demonstration. TV could unite the nation instantly.
And this is happening elsewhere too, right? TV going global.
For sure. Canada's CBC started TV broadcasts in 1952. France actually had a channel way back in 35, though low res, later moving to 455 lines. The Soviet Union adopted a 625-line standard by 1946, which became common in Europe and started regular broadcasts in 48. Different countries, different standards, but television was definitely becoming a worldwide thing.
Speaking of standards, the picture was still black and white. The next big leap was color.
Right. Though, interestingly, the idea of color TV is almost as old as black and white. People were patenting concepts back in the late 1800s, early 1900s. LeBlanc, Schepanek, Adomian. It's not practical yet. Bell Labs showed a mechanical color system in 1929.
And Baird, the mechanical TV guy, he worked on color too.
He did. He showed a hybrid system with spinning color filters around 1939 and 1940. Later in the 40s, he was working on an all-electronic color system called Telechrome, even demonstrated a 3D version.
3D color in the 40s.
Yeah, but unfortunately he died in 1946, and that work kind of stopped. And in Mexico, Guillermo González Camarena patented his own color system in 1942, so lots of parallel efforts.
But the big challenge was fitting color into the existing broadcast system, right? Without using tons more bandwidth and making it work on old black and white sets.
That was the multi-million-dollar question. How do you add color information efficiently and, crucially, make it compatible? You don't want millions of existing black and white sets to suddenly become obsolete.
So how do they solve it in the U.S.?
After a lot of debate and competing systems, the FCC approved the NTSC standard in 1953. NTSC stands for National Television System Committee. It was a really clever piece of engineering, mostly driven by RCA.
What was so clever about it?
It squeezed the color information into the existing black and white signal structure. Black and white TVs would just ignore the extra color data and show a normal picture, but new color TVs could decode that extra info and display the color, compatible color.
Okay, so the tech is ready in 53.
Yeah.
Did everyone rush out and buy color TVs?
Not at all. It was a really slow burn. First, color sets were super expensive, like luxury item expensive. And second, there was hardly anything broadcast in color. Why buy a pricey color set to watch black and white shows? The first national color broadcast was the Rose Parade in 1954, but that was mostly a showcase. For years, most programming stayed black and white.
So when did color actually take off?
The tipping point was really the mid-1960s. Set prices started coming down, and critically, the networks made a big push. NBC, owned by RCA, which made the sets, led the way. By fall '65, over half of primetime shows were in color.
The color transition I've heard about.
Exactly. The 1966 season was the first where basically all primetime network shows were in color. Though daytime soaps and game shows took longer, the last ones didn't switch until 1972. That marked the first fully color season across the board.
And portable color sets probably helped too.
Oh yeah, absolutely. GE brought out the Portacolor in '66, made it much more accessible than the huge, heavy consoles. And 1972 was also the year that sales of color TVs finally overtook black and white sales in the U.S. That was the real sign color had arrived for the masses.
So by the mid-70s, black and white was pretty much done in the U.S. What about Europe? Did they use NTSC?
Mostly no. Europe largely adopted two different standards in the 1960s, PAL and SACAM.
What different ones?
Well, technically, NTSC had this known issue, a slight color variation sometimes called the tint problem, that needed manual adjusting. PAL and SACAM were designed to fix that automatically, but there were almost certainly political and economic reasons, too, protecting domestic manufacturers, national pride, you know the drill.
Right. So that's why you used to need different TVs or VCRs depending on the country.
Exactly. That incompatibility was a headache for decades.
Okay, so we've gone from mechanical flickers to electronic black and white, mass adoption, then color. What's the next big chapter? How the signal gets to the TV.
Precisely. We move beyond just signals through the air, enter cable and satellite television.
Cable first. That's signals through wires, right?
Correct. Coaxial cables initially, later fiber optics. Cable really exploded in the U.S. in the 70s and 80s. Its big advantage was offering way more channels than you could get over the air.
And that changed things for the big networks.
Hugely. It fragmented the audience. Instead of everyone watching one of three networks, viewers spread out across dozens, then hundreds of channels. Led to niche programming, 24-hour news, all sorts of things. Cable also started analog and eventually went digital too.
Okay, then satellite. Beaming signals down from space. Arthur C. Clarke predicted that way back in 1945.
Incredible foresight, wasn't it? Satellite TV actually started kind of indirectly from cable. Cable companies needed a way to get signals to their local distribution points, their head-ins, especially in rural areas. So channels like HBO, TBS, PBS started using satellites for that distribution.
And then people at home figured out how to pick up those signals themselves.
Exactly. Tinkerers and enthusiasts started building their own receiving systems. Taylor Howard built the first home C-band system in 1976. Then, in 1979, the FCC said you didn't need a license to own a satellite dish.
But those early dishes were enormous, weren't they?
Oh, massive. 10, 15, even 20 feet across. And incredibly expensive. That first commercial one in the Neiman Marcus catalog, $36,500 in 1979.
Wow. So definitely not for everyone.
Not initially, no. It was mostly for wealthy enthusiasts or people in remote areas with zero broadcast reception. For them, it was amazing, lots of channels, often free once you bought the dish because the signals weren't scrambled yet. Prices did come down, though, to maybe $2,000 by the mid-'80s, and sales picked up.
But the giant dishes caused some issues. People didn't like the look of them.
Yeah, the backyard behemoths became controversial. Eyesores, some called them. Homeowner associations tried to ban them. That led to legal fights, and the FCC eventually stepped in '86 and said most restrictions weren't allowed.
But as more people got dishes, the channels being beamed down weren't happy about everyone watching for free.
Exactly. That's when scrambling started. HBO began scrambling its signal in the mid-'80s using systems like Video Cipher Second. You had to pay a subscription fee to get a decoder box.
Which created the satellite pay TV business, but also piracy.
Oh, yeah. A huge black market sprung up for illegal descramblers. It was a real cat-and-mouse game.
And wasn't there some famous protest about the scrambling?
The Captain Midnight incident, yes, in 1986. A disgruntled satellite dealer hijacked HBO's signal for a few minutes to broadcast a protest message against the scrambling and subscription fees. Made national news.
Huh. So what happened then? Did scrambling stick?
It did. The channels eventually offered legal subscription packages directly to dish owners, although often at prices people complained about. And the government cracked down hard on piracy with hefty fines and jail time via laws like the 1992 Cable Act. The era of free C-band TV was pretty much over.
So how did satellite TV evolve from the giant dish era?
Technology moved on. New satellites were launched that were much higher power and used different frequencies, the Ku band, like Astro 1A in Europe in '88. These allowed for much smaller dishes, maybe 90 centimeters or about 3 feet.
Much more manageable.
Way more.
Yeah.
And then in the U.S., in the mid-'90s, you got DirecTV and Dish Network launching. They used digital signals and even higher frequencies, allowing for those really small 18-inch dishes we see today. Digital compression also helped pack more channels in. These small digital systems basically killed off the old giant C-band dish market for consumers.
Any downsides to the smaller dishes and higher frequencies?
The main one is rain fade. Those higher frequency signals can be absorbed or scattered by heavy rain or snow, causing temporary signal loss, something C-band was less prone to.
Okay, so cable and satellite changed how we got TV. That brings us to the latest huge shift, digital television. DTV.
Hey, this is probably the biggest revolution since color, transmitting the picture and sound as digital data ones and zeros instead of an analog wave.
What made that possible?
Basically, cheap computing power. By the 1990s, digital processing chips were powerful enough and affordable enough to build into TVs and broadcast equipment.
And DTV is tied up with high-definition HDTV.
Absolutely. While Japan experimented with an analog HDTV system early on, the U.S. really pushed for a digital standard for high definition. The FCC made some key calls in 1990. They said the new standard had to deliver true HD quality, much sharper than analog. And they allowed stations to broadcast both analog and digital simultaneously for a while during the transition.
I remember there was some debate about how the picture should be scanned digitally. Interlaced versus progressive.
Yes, a big fight, actually. Broadcasters and TV manufacturers who had invested heavily in interlaced technology for decades generally preferred sticking with interlaced scanning for HD.
Because it was familiar.
Familiar and cheaper to implement initially, arguably. But the computer industry and the film industry argued strongly for progressive scanning where every line is drawn in sequence. They said it looked better, especially with motion, had no flicker, and was naturally compatible with computer monitors and digitally originated movies.
Who won that one?
The FCC kind of compromised. They allowed both interlaced, like 1080i, and progressive, like 720p or 1080p formats within the official ATSC digital standard. Let the market decide to some extent.
And then came the big switch off of analog.
Right, the digital transition. It happened over several years, but in the U.S., analog broadcast largely ended in 2009. Many other countries transitioned in the late 2000s, early 2010s. You had to get a new digital TV or a converter box for your old analog set to keep watching over-the-air channels. A pretty major upheaval for consumers.
And digital TV, combined with the internet, led to smart TVs.
Exactly. That's the convergence we're living through now. Smart TVs really took off in the 2010s. They're basically computers built into your television. Internet connection, apps, streaming services like Netflix, Hulu, all integrated. They pretty much become the default type of TV you buy now.
It's just incredible thinking back, that 8x8 pixel image.
Yeah.
To these massive internet-connected HD screens. We went from mechanical spinning discs through electronic tubes, those huge patent fights between Farnsworth and RCA.
The post-World War II boom that put a TV in almost every home.
Adding compatible color, which took surprisingly long to catch on.
Then cable and satellite blowing open the number of channels.
And finally, the digital revolution giving us the clarity and connectivity we have now.
It's a fantastic story of invention, sure, but also business strategy, government regulation, and just massive shifts in how we live and consume media. It shows how fast technology can utterly transform society.
It really does.
Yeah.
And thinking about that constant evolution, that constant change, here's something to ponder. We've seen TV shaped by technological leaps, but also by those business battles and regulatory choices like the NTSC standard or the satellite scrambling fights. How does understanding that history, the economics and the rules of the game, help us maybe understand the challenges and the power struggles happening right now with new media technologies, streaming platforms, AI, content generation, whatever comes next?
That's a great question. The players change, the tech changes, but some of those fundamental dynamics of innovation, competition, and control, they often echo through history.
Definitely food for thought. Thanks for joining us for this deep dive into the history of television on Seeking History.